Every second of every day, electricity travels thousands of miles from where it's generated to power your home, your office, and your city.
This vast network operates through 5 interconnected systems. Generation, where energy is produced. This vast network operates through 5 interconnected systems. Generation, where energy is...
Hi there, I'm a distribution network specialist here at the utility company. Today, I'm going to take you on an exclusive tour of how we manage the power grid.
Every day, utility companies.
Once extracted, coal enters preparation facilities where it's crushed to optimal size, removing excess rock and impurities.
Natural gas serves as another critical fuel source for electricity generation. Extracted from deep underground reserves, natural gas serves as another critical fuel source for electricity generation. Extracted from deep underground reserves.
Renewable energy is transforming the utility landscape. Solar farms harness the sun's limitless power.
Wind energy represents one of the fastest-growing renewable sources globally. Modern wind turbines are engineering marvels.
Hydroelectric power harnesses the gravitational energy of falling water, one of the most reliable and efficient renewable sources.
Transportation of raw materials is a logistical marvel. This single coal train carries 10,000 tons of fuel.
Natural gas travels through thousands of miles of underground and above-ground pipelines at pressures exceeding 1,500 psi.
Water is essential for power generation, cooling turbines, and condensers.
Quality control begins before fuel ever reaches a power plant. Every shipment undergoes rigorous laboratory.
Modern power plants incorporate sophisticated environmental protection systems. Electrostatic precipitators.
After traveling hundreds of miles, fuel arrives at the power plant, where it's received, inspected, and unloaded.
The boiler is the heart of thermal power generation. Before ignition, technicians conduct
Coal combustion begins with precision burners injecting pressurized coal dust and air into the combustion chamber.
Dredges. The boiler's tube surfaces are covered with thousands of square feet of heating surface. Water continuously circulates through.
Superheated steam represents the peak efficiency point in thermal power generation. By raising steam temperature, the turbine is where thermal energy converts to mechanical energy. This 600 megawatt turbine weighs.
The high-pressure turbine stage receives steam at 1,000 grade.
Steam exits the high-pressure stage at lower pressure but still high velocity. The intermediate pressure stage.
The low-pressure turbine stage receives nearly spent steam at near-atmospheric pressure. These massive. The turbine and generator are mechanically coupled by a solid shaft. The coupling is engineered to transmit full turbine.
The generator rotor contains powerful electromagnets that create a rotating magnetic field.
The stator windings capture the rotating magnetic field's energy as alternating current. 3-phase design with 100 kV. From the generator, electrical current flows through protection systems, ensuring grid stability.
The turbine's steam exhaust enters the condenser at low pressure. Cooling water flows through thousands of tubes.
The complete power generation cycle transforms fuel's chemical energy into electricity through a series of
Feed water pumps pressurize condensed water back to boiler pressure. These pumps handle 6 to 8 million gallons.
Transmitting electricity over hundreds of miles requires very high voltages to minimize power losses.
The transformer's magic lies in electromagnetic induction. Primary windings carry input current.
The circuit breaker is among the most critical components protecting the transmission system. This oil-filled transmission towers supporting multi-ton steel structures and conductors require massive foundations. Engineer calculations account for Modern transmission towers are engineering marvels. Steel lattice design provides enormous strength.
Transmission conductors are typically aluminum steel composite to balance conductivity with strength. These conductors carry 4
At 345,000 volts, the electric field strength around conductors is extreme. In wet
Lightning is a transmission system's enemy. Ground wires running above the phase conductor.
Transmission line sag is carefully managed through engineering design. Lines are strung with calculated tension, accounting for temperature extremes.
Major substations are the heart of the transmission system. This substation interconnects 5
Step-down transformers at major substations reduce transmission voltage to distribution voltages suitable for regional networks.
Inside this substation, power flows following the path of least electrical resistance. From the transmission substation, distribution feeders carry power toward neighborhoods. These circuits, typically 60.
Distribution transformers are the final step before power reaches customers. These ubiquitous devices, found on nearly every...
The distribution system is far more complex than transmission. Thousands of miles of distribution lines branch.
Voltage regulators automatically maintain stable voltage.
Inductive loads like motors and transformers consume reactive power, reducing real power delivery efficiency. When a fault occurs, perhaps a branch on a line, the recloser detects it and opens the circuit.
Smart meters revolutionize customer service and grid management. Traditional mechanical meters measure monthly consumption.
Underground distribution systems are increasingly popular in urban and residential areas. High-voltage cables rated for
The service drop is the final link connecting utility infrastructure to the customer. 2 or 3 conductors carry power.
Large customers like factories or office buildings receive power through dedicated service connections, often rated for
Demand response programs are increasingly important as utilities manage peak demand.
Modern outage response is remarkably fast and coordinated.
The Network Operations Center is the command hub where every network monitored.
SCADA systems process an immense volume of real-time data. Large utilities process over 100,000.
Voltage stability is critical to customer equipment longevity and grid reliability. Utilities maintain voltage within 5% of nominal.
When demand suddenly increases, all generators slow slightly, frequency drops. Sophisticated automatic
Equipment life depends critically on operating temperature. Transformers designed for 65 degrees hottest spot temperature.
Transformer insulation condition is critical to equipment life. Oil-insulated transformers have insulation paper that degrades with...
Protective relays are the grid's immune system. They must respond instantly to faults, isolating damaged equipment before cascading failures occur.
Modern power systems contain increasing nonlinear loads injecting harmonic distortion. Variable frequency drives on
The power grid is an essential critical infrastructure increasingly vulnerable to cyber attacks. Utilities implement multi-layered cybersecurity.
Resilience is built into every critical grid system through redundancy. Transmission substations have backup.
Environmental responsibility is integrated into modern utility operations. Continuous monitoring ensures compliance with
Modern utilities manage thousands of major assets, such as transformers, circuit breakers, transmission lines, and generators.
Skilled utility operators are essential to grid reliability. Operations personnel require 2+ years of training before
Utilities invest heavily in research and development, preparing for future challenges. Grid modernization projects test advanced technology.
Renewable energy integration is transforming grid operation. Wind and solar have zero marginal cost once installed, but
Energy storage is the missing piece, enabling high renewable penetration. Battery storage systems costs have dropped 85%.
Microgrids are transforming grid resilience by enabling communities to operate independently during grid disruptions.
Electric vehicle adoption is transforming the grid. Millions of vehicles represent distributed battery storage capacity.
Smart homes represent a new paradigm where customers actively participate in grid operations.
Demand-side management programs recognize that reducing customer energy consumption is often more cost-effective than building new.
We've just scratched the surface of how modern electric utilities manage one of the world's most complex systems.
The grid of tomorrow will be fundamentally different from today's system. Distributed renewable.
Subscribe for more behind-the-scenes factory tours and process documentaries. Hit the notification bell to stay updated on new videos. Check out these related videos.
Special thanks to Turns and Brew and all the dedicated professionals making the modern grid possible. This